Solving a system of linear equations by substitution. So there is no graphing in this one. You are doing it algebraically alone. It still means the same thing though. What you're looking for is that intersection point. So what point satisfies both equations? Solving a system of linear equations by substitution. A system of linear equations is two or more equations. The number of equations must equal the number of variables. Our focus will be on two linear equations. Solving a system is finding the intersection points. Substitution is algebraically replacing what one variable equals in one equation into that variable in the second equation. So if I have 3x plus 4y equals negative 8, and I have 2x minus y equals 13, I choose a variable to solve for. Priority is a variable that does not have a coefficient shown. So the x here has a 3 for the coefficient. This one has a 4. This one has a 2. This has a negative 1. And a negative 1 I can deal with. I'd rather have it plus y, but I can deal with a negative 1. So that's the equation that I want to solve for first. So I'm going to take this second equation, 2x minus y equals 13. And I'm going to solve for y. So I'm going to subtract 2x from both sides of the equal sign. I get negative y equals negative 2x plus 13. I want a positive y, so I'm going to multiply through by the negative 1. That will give me positive y equals 2x, positive 2x, minus 13. Now I take that 2x minus 13 and I go to my first equation and I put it in for the y in my first equation. So I have 4 times y. Well, instead of 4 times y, I'm going to have 4 times 2x minus 13. So 3x plus 4 times 2x minus 13 equals negative 8. Now I distribute, combine similar terms, and solve for the x, because I have one equation with one unknown. So solving for x, I have 3x plus 8x, so that's 4 times 2x, minus 52. 4 times negative 13 is a minus 52, equals negative 8. 3x and 8x give me 11x. If I add 42 to both sides, I end up with a positive 44 on the right-hand side. 11x divided by 11, 44 divided by 11 will get me my x alone, so I have x equal to 4. Now I substitute the 4 in for the x in what I got here, y equals 2x minus 13, because I need to know what y is also. So when I substitute that 4 into the x, I have y equals 2 times 4 minus 13. 2 times 4 is 8. 8 minus 13 is a negative 5. So my solution is x is 4 and y is negative 5. Hence, the point of intersection would be 4, negative 5. Example 1. I have 2x minus 5y equals negative 16. And I have x plus 7y equals 11. So I want to solve for x in equation 2. Solving for x in equation 2 means that I'm going to have x plus 7y equals 11. So that's my equation 2. Reason why I'm solving for x is because it's just x here. So it's easier. So I subtract 7y from both sides of the equal sign. I get x equals 11 minus 7y. I take what x is equal to, and because I use the second equation to solve for x, I plug it into the first equation. So I now have 2 times 11 minus 7y minus 5y equals negative 16. 2 times 11 is 22. 2 times negative 7 is negative 14. So I have negative 14y minus 5y equals negative 16. So 22, if I move that to the other side, I'm going to be subtracting it. Negative 22 and negative 16 is a negative 38. And negative 14y and minus 5y gives me a negative 19y. So I have negative 19y equals negative 38. I want to get the y alone. I divide both sides by negative 19. Y will equal 2. Now I put that back into this equation that I had solved for by using equation 2. So I have x equals 11 minus 7. My y is 2. So 7 times 2 is 14. 11 minus 14 is negative 3. So my x is negative 3 and my y is 2. So my point of intersection is negative 3, 2. Example 2. I have 10x minus y equals negative 2, and I have negative 5x plus y equals 7. Okay, the y is negative here, and it's positive here, but there's otherwise the coefficient in front is a 1, which isn't going to change anything. So I'm going to use the second one so that I don't have to divide by negative 1 in the end. So I'm going to use negative 5x plus y equals 7. So negative 5x plus y equals 7. I add 5x to both sides. I get y equals 7 plus 5x. Now I take this and I put it into the other equation for the y, because that's what y equals. So I have 10x minus y equals negative 2, which changes to 10x minus the quantity. 7 plus 5x equals negative 2. I distribute out this negative sign, then I have 10x minus 7 minus 5x equals negative 2. 10x and minus 5x gives me a positive 5x. And if I move the negative 7 to the other side, I would be adding 7. Negative 2 plus 7 is positive 5. So I have to divide both sides by 5 to get the x alone, so x is equal to 1. I take that 1, I plug it into this equation that I solved for before, and I have y equals 7 plus 5x, replace the x with 1, 7 plus 5 times 1, which is 7 plus 5, which is 12. So my point of intersection is 1, 12. Third example, 5x minus y equals negative 22, and 8x minus 6y equals 0. Okay, I'm looking for the x alone or the y alone. No coefficient shown, which means that it's 1. So I have the negative y, which I'll deal with. So I'm taking 5x minus y equals negative 22. I subtract 5x from both sides. I get negative y equals negative 22 minus 5x. I multiply through by a negative 1 because I need to solve for y, not negative y, and I get y equals 22 plus 5x. I plug that in for the y in the equation that I did not use, and I have 8x minus 6 times 22 plus 5x equals 0. I distribute my minus 6 to what's inside the parentheses, and I have 8x minus 132, negative 6 times 22, minus 30x equals 0. I move the 132 to the other side so it becomes positive when I move it, and negative 30 and 8 give me negative 22. I divide both sides by negative 22, and x is equal to a negative 6. I take that negative 6, I plug it in for the x, and y equals 22 plus 5x. So I did that over here, and I have 22 plus 5 times negative 6. 5 times negative 6 is negative 30. 22 minus 30 is negative 8. So my x is negative 6, and my y is negative 8. So my point of intersection is negative 6, negative 8. In summary, solving a system of linear equations by substitution. Substitution is algebraically replacing what one variable equals in one equation into that variable in the second equation. The final answer is the intersection point of the two lines.